Okay, the next thing that we're going to look at is transforming graphs of exponential and logarithmic functions. Now, these are the same principles apply that we used in the previous 6 examples. Nothing changes here. The fact that it's an exponential or logarithmic graph is totally irrelevant. That's not the point here. The thing is what we do with the transformation. So let's take a look at example 7 here. It says, shown is the graph of the function f of x is equal to 2 to the power x. To the diagram opposite, add the annotated graphs of the functions y is equal to 2 to the power x minus 3 and y is equal to 2 to the power of, and all in brackets, x minus 2. So I am going to do the first transformation in red, and I'll do the second transformation in blue. Now, the important thing to realise here is, if this is a graph of y equals 2 to the power x, if I then want to sketch the graph of y is equal to 2 to the power x, take away 3, well, that's just a value it's outside, there's no bracket there, so it's outside the bracket, it's going to affect the y values, and this is just going to move the graph down 3 places. Okay, so as usual, let's start off with the points we've got. So we have the point 0, 1, and we have the point 2, 4. So if I was to move 0, 1 down 3 places, 0, 1 goes to 0 minus 2. If I was to move 2, 4 down 3 places, that goes to 2, 1. So 0, 1 goes to 0 minus 2, and 2, 4 goes to 2, 1. And that graph just looks like this. So it's the same as the black graph, but it's just been moved down 3 places, and that's a graph of y is equal to 2 to the power x, take away 3. Now let's go back to the original black graph, and we'll sketch the graph of 2 to the power of, in brackets, x minus 2. So our coordinates are, again, 0, 1 and 2, 4. So what we notice here is that we have a minus 2 inside the bracket. So remember our rules of transforming graphs. When we have a number inside the bracket, it affects the x and does the opposite. Y stays the same. So instead of taking away 2 from the x values, we're going to add 2 to the x values. So that means that 0, 1 becomes 2, 1, and 2, 4 becomes 4, 4. So let's transform that then. So 0, 1 goes to 2, 1, we already have that there, and 2, 4 goes to 4, 4. And I'll draw that approximately here. And then we just sketch the graph. So that's then going to look something like that. Okay. Yeah, it's probably going to be a bit more like that. Take this bit at the bottom here out, because we're just moving that across the way. So it's going to look like that. And that is a graph of y is equal to 2 to the power of, in brackets, x minus 2. So the principles that you learned from the previous examples still apply here with these types of graphs. So just watch out for values that are outside the bracket or values that are inside the bracket. The next one we're going to look at is logarithmic graphs. So shown is a graph of the function y equals log to the base 5 of x, and we're going to add to this graph the annotations of y equals 2 times log to the base 5 of x, and y is equal to log to the base 5 of x plus 1. So we'll do the first one in red here. So let's write down our coordinates. The coordinates are 1, 0 and 5, 1. So you'll notice here that we have, to the black graph, which is log to the base 5 of x, we have a 2 multiplying that. Okay, so this is a k times f of x graph. When we multiply a number bigger than 1, that has the effect of stretching the graph. And because it's on the outside, it affects the y's. So we're going to multiply our y variables by 2 and keep the x's the same. So 1, 0 stays as 1, 0 because 0 times 2 is 2. 5, 1 becomes 5, 2. So 1, 0 stays the same. 5, 1 becomes 5, 2. And that is going to look something like this. And that's a graph of y is equal to 2 times log to the base 5 of x. The final transformation here is sketching the graph of log to the base 5 of x plus 1. So we have the points 1, 0 and the point 5, 1 from the original graph. So if the original graph represented the graph of log to the base 5 of x, we now have in brackets this plus 1. So the numbers inside the bracket, so we do the opposite to the x, keep y the same. So the opposite of plus 1 is take away 1, so we take 1 away from the x values. So 1, 0 goes to 0, 0. And 5, 1 goes to 4, 1. So 1, 0 goes to 0, 0. And 5, 1 goes to 4, 1. So that graph will look something like that. And that's a graph of y is equal to log to the base 5 of x plus 1. So it doesn't matter if it's an exponential graph or a logarithmic graph or any other type of graph. Those 6 principles that we've already learned about shifting the graph up and down, left and right, stretching and compressing both horizontally and vertically, as well as flipping, those same rules apply for whatever graph you will ever face in higher maths and beyond.